Welcome to the 555 timer lecture. The 555 timer is a little 8-pin IC, and it's capable of doing a lot of timing functions. And it's all based on RC curves, charging and discharging curves of the capacitor. They're exponential and they're well known for charge and discharge. And since they're we could calculate based on those curves. We could use this as a very precise or semi-precise timing device. Here is the resistor capacitor charge and discharge chart. What we go by here is RC, one time constant. So time constant would be resistance times capacitance. And the charge increases by 63.2% each time constant. So the first time constant, we're going to go from 0 to 63.2% charged. And every time constant after that, we're going to go up by another 63.2% of the remaining. So the second time constant is going to be 86.5, 95, 98, and we start approaching at 100%. As we discharge, we're going to start at 100 or close to it, and we're going to go down to 36.8%, 13.5%, 5%, 2%, and close to zero. We're going to consider that a capacitor is fully charged in 5 time constants. There are two basic configurations of the 555 timer. Even though there's many different functions this device could do, the two basic ones we're going to look at is a monostable or one-shot. When it's triggered with pin 2, based on this resistor and capacitor, it is going to make a single pulse. It's called a retriggerable pulse that we could retrigger many times. And once we trigger it, we release it, and it will time out and make a timed pulse based on this formula. Here's the inside workings of a 555 timer in the monostable. The monostable you can recognize because it's going to have one external resistor and one capacitor. So it's going to charge this capacitor through this resistor. So this RC time constant is going to allow us to charge and discharge necessarily to be between these 2 points here. We have comparators. There's 3 equal resistors, voltage divider, and what we're going to do is we're going to go between 2/3 and 1/3 of VCC. And this is a one shot, so it's only going to do it one time. This is the typical capacitor charge curve, and once it hits the 2/3 point, it is going to change the position of these comparators, and it's going to flip this latch in order to reset. So based on these two sizes, we trigger it here, and it is going to make a time pulse based on that RC circuit, based on the charge pattern of our capacitor. Here's the end of the pulse diagram of the 555 monostable. We're going to, once we charge this, which we've done already, it's going to discharge once it hits this 2/3 point. Okay, we're going to discharge this capacitor through our transistor to ground, and it is going to turn that device off, and it is going to go down to the 1/3 position and wait for it to be retriggered. Here's a schematic for the astable. The astable timer will put out a continuous pulse at a frequency and pulse width that we designed based on these 2 resistors and this capacitor. And you can tell this is the astable because we have 2 resistors and 1 capacitor. Here's a diagram of the A-stable timer with the internal components inside this box and the external components which we add. We have two resistors and one capacitor, and they're going to charge off this 9 volts until it gets up to 2/3. Okay, so we have our 3 internal voltage divider on. So we have 1/3, 2/3, and the last. And what we're going to do is we're going to go between 1/3 and 2/3, 3 volts and 6 volts. So what we're going to do is we're going to charge from 1/3 to 2/3, and then we're going to discharge 2/3 to 1/3 and charge and discharge. And based on this capacitor curves, we're going to get a square wave output. Here's a diagram of our A-stable 555 timer. Once it's completely charged, it is going to go up to the 2/3. This comparator is going to change. Our RS latch will change, and it'll turn on this transistor. And we're going to discharge through this transistor back to ground. So we go up to 2/3. We're going to switch this transistor on. It's going to drain the capacitor. It's going to go back down, switch it, and turn the transistor off, and it's going to recharge and discharge back through this cycle. And if you notice here, we're going to charge through 2 resistors, and we're going to discharge through just one of the resistors. And that's going to set up our pulse width and duty cycle of our output.